All right. So, and then there's one particular type of integrated circuit that we just want to go over. This is, so typically, like basically the most common thing that you want to do is make a signal bigger or smaller, right? So you want to amplify it. So usually you start with, and this is time changing just to make it clear that there's something changing. You start with something that's small and you want to make it big, right? You have a sensor that is going to just change by a few millivolts, but the thing that you're going to read it out with, you want that change to be in the multiple volts range. So that's called amplification. A less common task, but sometimes you still need to do it, is you make the signal smaller. That's attenuation, right? And the ratio of this input to output, that's called the gain. So in this case, the gain is greater than 1. And in this case, the gain is between 0 and 1. And if the gain was less than 0, that's where you're actually taking a positive signal and changing it to negative, right? So the chip or the integrated circuit that you're going to use to do this is called an op amp. This is basically probably the most important and prevalent circuit, that is our integrated circuit that's used. So they have this standardized triangle symbol. Most other integrated circuits that you're going to run into, they're just going to be a block on the schematic that have a bunch of pins coming out of it. But because op amps are so common, they have this particular symbol used. So you have 2 inputs on the backside, you have 2 power supply connections, and then you have an output connection. So the positive and negative power supply, which you call VCC plus or VCC minus also, those are basically that is where the power for this chip is coming from, and the output is limited within the range of these 2 chips, or these 2 values. So you may have 0 and a positive voltage, but you may also see a positive and negative voltage. So that would be like +5, -5, or +12, -12, or it may be like 0 and 5, right? And the reason you would possibly have a negative power supply connection is if you're building a circuit and you want the capability of the output to go negative, right? So, and then the other important thing is whatever current is going through this output, because a common use for these things is to drive a larger, something that takes more current. You want a signal that you have some signal you're monitoring, but the thing you're sending the signal takes more current. You supply that current from the supply pins rather than the input pins. And then you have 2 inputs, again, plus and minus. Usually, if you just say V plus or V minus, you're talking about the inputs. Sometimes you may see that referring to the power connections, which is confusing and not great. So these are also called the non-inverting input and the inverting input. Usually the signal you feed into the non-inverting input is a positive signal that you want to come out to be positive. Whereas the inverting input is like if you have a negative signal and you want to change it to be positive, or you have a positive signal and you want the output to become negative, right? But also you will use, if you can do addition and subtraction of 2 signals, so you can get the difference between the 2 of these, or you can add them together. And in those cases, you'll feed the signal you're subtracting into the negative input, or if you are trying to get an offset, so you want to shift the entire signal up or down, you will feed it into the inverting input if you want to shift it down. If you want to shift it up, you usually just add a second signal into the non-inverting. Usually when you're building one of these circuits, you have some input signal, you call that V in, And that's going to be connected to one of these things. But typically you don't have two V-ins unless you're doing the case where you're actually subtracting the difference between those two circuits. The output, V out, this is the thing that, you know, you are building a circuit to control what V out is doing. What you will usually see is this output is connected back either to the inverting input, V plus or V minus, or it is connected back to V plus, the non-inverting input. And that's called your feedback loop. And that is how the op amp will actually be able to control its output. If it's not connected back to one of these inputs, there's no real like feedback. So the op amp won't actually really amplify. Like I said, the range of values that you can get on this output is between whatever you have on the positive power supply and the negative power supply. So when you're designing or building one of these, you consider, okay, where do I need this output to be? Therefore, I have to have these values on the power input. Okay. And what happens on this output is going to change depending on what you call the op amp golden rule. And we'll cover those in a second. I know this is a lot. When we get back to actually building one of these, we'll refer back to this. I just want you guys to get experience with this first. So the relationship between the output and the input is, you know, is going to be a linear equation. You call that the transfer function, right? Where the slope of this line is referred to as the gain, and then the offset is just called the offset, right? So in this example, you have like a small 450 to 800 millivolt signal, and you want to turn it into a 0 to 3 volt signal. That gives you the equation of this line. And if you, it's a little bit hard to read, but it has a slope of about 8.5, and it has an offset of like 3.8. But you can have all kind, that gain can be in thousands, and like I said, it can be negative, or it can be between 0 and 1. So the way that if you just have a circuit and you're like, I don't know what this is actually going to do, what's going to happen is the op amp is going to change V out so that the difference between the two inputs is 0. So that basically, so they're at the same voltage. And then the other rule is that current cannot flow in or out of the inputs, right? So it's going to modify this pin here so that pins 2 and 3 are at the same voltage, but you can't have any current going into pin 2 or out of pin 2 or into pin 3 or out of pin 3. So what does that actually look like? So simplest case here is what you would call a buffer circuit. So basically this doesn't increase or decrease the signal. All that it does is it gives you, it sort of isolates the input from the output. So in this case, right, we have V in at V connected to V plus. We have the output connected back to the inverting input V minus, right? So by the golden rule, V plus equals V minus, right? But that means V minus equals V in, right? Because there's nothing connected in between these. And then since the output is directly connected to V minus, that means V out is equal to V minus. And through, you know, those three equations, you get V in equals V out, right? So this is a circuit that has a gain of 1, right? It is basically the output should be equal to the input, but the reason you build something like this is, like I said, because you usually want to isolate whatever your input is from your output. Like this is maybe like a super sensitive sensor, and then you have some output that you're trying to drive that needs a lot of current. So in this case, all the current comes from here, and you don't mess up the thing that's driving. So like a slightly more useful circuit that actually creates an output is you put a resistor here that's called a feedback resistor. And now you can have a little bit of current come through here, and now all the voltages aren't the same, right? So if you run through and you do all of the Ohm's law and you're like, okay, the current coming through here can't go into 2, so all of it has to be here. If you do all of the calculations and you're saying, okay, the difference of voltage, you get these equations here, right? And we're not going to go through all of these, and I don't expect you guys to, but that's how the circuit analysis for this sort of stuff works. And so you can see I have 2 equations here, right? And I have V out here, and I have V in here, and I can substitute for V minus in this bottom one, and the resistors are just fixed values. And if you do the algebra, you get this relationship between V out and V in, right? And like I said, since this is the slope of the line, that tells you what the gain is, right? So the gain is just the 1 plus the ratio of these resistances. And you can build all kinds of, different circuits, and they are all going to have slightly different transfer equations. But usually you're just going to look up, I need one of these standard amplifying circuits. How do I build one of these? And what is the equation for that? So the basic ones are the buffer, right? Where it's just a gain of 1. The non-inverting amplifier, where you have a gain of between 1 and greater than, like 1,000. An inverting amplifier, which is where you change the sign of the symbol, so your gain is actually -1. And then you can have a summing amplifier, like I said, where you're adding V1 plus V2 to get V out. A difference amplifier, where you are getting the difference between V1 and V2. And then the final thing that you can usually do is you take one of these simpler ones and you shift it up or down. So you add an offset. So sort of final note on these things is like what sort of types and packages. So a lot of times you'll get multiple of these op amps packaged into a single chip. It's called a dual op amp. If you have 4 of them, that's a quad op amp, right? And then different ones will be designed to have different plus or minus values on the supply. And then sometimes you get different frequency. So if you have time dependent, like I said, sort of the last thing you would do is you would maybe add an offset, and then if you add capacitors or inductors to these, you can make that gain dependent on the frequency of the signal. And the reason you want to do that typically is you want to filter out some kind of noise, right? So you can filter out high frequency noise by adding capacitors. Basically, you make the gain much smaller for high frequency signals, so they get filtered out. All right. So that's it. Do you guys have any questions, especially for that op amp stuff? That's more, we'll come back to that and refer to that later, but I just wanted to introduce that now.